Hi, this is Charles Maggio. Welcome back once again to our For Epidemiology. And in this screencast, I want to continue our discussion or complete our discussion of categorical data analysis in R. And I want to take on the subject of stratified data in the setting of confounding and how you might be able to calculate a Mantel-Haenszel odds ratio in R. So, in the previous screencast, when I introduced categorical data analysis, we used epitools, specifically the epitab function. If you are interested in calculating a Mantel-Haenszel odds ratio, the tool you would need is actually in a different package. It's in a package called epicalc. And epicalc is really a very nice suite of packages. And this illustrates something that I think is important about R. You will find different tools that will meet your needs potentially in different packages. So you'll have to bring them in. You'll have to look for them. You can always, if you want, copy functions from any package and save them within your own library. In fact, RStudio makes it pretty easy to make your own package of your own functions if you want to do that. But in any event, what we want to do is use the epicalc package. If you haven't installed it, use install packages and then epicalc in quotation marks. I already have it installed. I'm going to bring it in with epicalc. And the tool, the very first tool we need to use is called CC for case control, actually. If you bring up the help page for that, what you see is it says, the odds ratio calculation, for odds ratio calculation and graphing, and the arguments, there's a number of arguments. What I find is that epicalc is a little bit more verbose than epitools. Epitools really just get straight to the point. Epicalc actually has a lot of other tools that come along with it, some more bells and whistles, some very nice aspects, and some nice options to it. But the function we want to use is CC for case control, and the data set we're going to work with is the low birth weight data set. I believe we've seen it before. I'm going to read it in here, and if you want this URL, you can get it from the slides. If we look at the names of the birth data set, I'm reading in the raw data here into an object called births. If we look at the names, we see there are a number of names here. Low refers to a low birth weight birth. There's a variable for mother's age, mother's weight, socioeconomic status, whether she drank alcohol, whether there was a previous preterm delivery, histological hypertrophy, I believe. I think it's uterine hypertrophy. But anyway, there's another variable for uterine irritability, and I think this is one for number of physician visits or whether she's getting prenatal care. What we're interested in is the potential association between previous preterm birth and low birth weight and a subsequent birth. And the way we are going to calculate an odds ratio for this, we could have done it in epitools with epitab, doing it essentially the same way, but we're going to use the CC function from epicalc here and see the way it returns. And we are going to essentially basically just give the two variables in which we're interested in measuring an association between as arguments, and we get a nice little table here, and then the odds ratio of 4.32, which basically can be interpreted as meaning that there is 4 times as likely to have a previous preterm birth in a low birth weight, in a subsequent low birth weight birth. And the confidence interval for that ranges from 1.78 to 10.6, but it's real. As epidemiologists, we wouldn't stop there. We'd really be interested in figuring out, are there any other potential explanatory reasons, or what are the possible confounders in this setting? And one of the possible confounders that you would get from substance area knowledge is the presence of uterine irritability. You would, if you're an obstetrician, you might know this yourself, or if you're working with your clinical colleagues, you would say, well, what might account for this? And an obstetrician might say, well, there is clearly some association with uterine irritability and previous preterm birth, preterm birth in general, right? And there might be an association. Uterine irritability might be causally associated with our outcome of interest here. And what you might do then is, looking at your data, you are smart enough to measure uterine irritability. You would look at the association between your potential confounder and your outcome, and you would see that there really is an association here, about 2.5 times as likely. It is they're basically a significant association. The numbers are kind of small. I think if you had enough numbers, most of the the probability is on the side of the association. And then you would look to see, well, does this potential confounder seem to ride along with our potential exposure of interest, which is previous preterm birth. So we'll use the CC function once again and look at the odds ratio for the association between our potential confounder and our exposure of interest, and we see that we get a little warning message that the numbers are in fact pretty small, so this confidence interval and the p-value really might not be, but we're not as interested in that as we are in the actual association, and there is an association. At this point, what you might do is say, okay, well, I am interested in knowing how much this confounding might account for this relationship that I initially found between my exposure of previous preterm birth and my outcome, uterine irritability. One way you would do that is by looking at a Mantel-Haenszel odds ratio and then comparing this adjusted Mantel-Haenszel odds ratio. And there's any number of ways of doing this. And some folks might go directly to a potential, like a logistic regression, to sort of like evaluate it and look at the effect with and without the confounder. But certainly the way I learned, and I think the way classically and epidemiologically we start thinking about these things in terms of confounding, is by looking at a Mantel-Haenszel odds ratio, which is an adjusted odds ratio. And, nicely enough, in epicalc, there is a function called mhor for Mantel-Haenszel odds ratio, and the arguments are the outcome of interest, the exposure of interest, here preterm birth, and then finally the third variable, the possible confounding variable. If we submit that, we get this stratified analysis, stratified by variable 3, that third variable. And we could look at the strata-specific associations, whether variable 3 is not present or whether variable 3 is present. And we see that there is really some wide some wide difference between them. We'd have to really look closely at whether there's some sort of interaction going on there. But if we looked at the Mantel-Haenszel odds ratio, we'd see an association of 3.65. If you recall, scrolling up to our initial analysis, we saw that the odds ratio, the unadjusted odds ratio, was 4.32. The adjusted odds ratio is 3.65. Does that rise to a level of a meaningful change in the odds ratio? Partly it has to do with substance area knowledge, and it has to do with how important you think this potential confounder is. I would say it does. It would be a matter of discussion. But from the simple perspective of how to get an adjusted odds ratio for a simple 2x2 table, for a simple adjusted table, this is how you would do it. This is how I would do it within R. I would use the epicalc package and use the CC function and then the mhor function.